Hello and welcome back again. We're continuing our study on hypothesis testing for two samples. Last time we talked about hypothesis testing comparing two sample means. Today we're talking about hypothesis testing comparing two sample means again. But this time we're doing two sample means with small samples. Here we go. With sample sizes below 30 and unknown population standard deviations, we again use the t-distribution. When you're comparing the means of two populations, but you only have small samples, there are actually two different types of t-tests. Which t-test you use depends on whether or not the two populations have equal variances. If the two populations are normally distributed and do have equal variances, you use a pooled t-test for small samples. If two populations are normally distributed but have unequal variances, you use an unpooled t-test for small samples. On the TI-83 and TI-84 calculator, you're going to go to stat tests and down to two sample t-test. So let's try this out. The braking distance of 8 Toyota Camrys and 10 Kia Sedonas when traveling at 60 miles an hour on dry pavement were measured. The results are shown at the right. Can you conclude that there is a difference in the mean braking distances of the two types of cars? Assume the population variances are not equal, and we're going to use the 0.05 significance level and p-values. So our hypotheses are that the means are equal for the null, or for the alternate that the means are not equal. We've got a 0.05 significance level. We're using a t-distribution two-tailed test. So our rejection rule would look like this. If p is less than 0.05, we'll reject the null. If p is greater than or equal to 0.05, we'll fail to reject the null. Straight to the calculator, we're going to go to two sample t-tests, go over to stats, and we're going to plug in the summary statistics data. You're going to want to choose a two-tailed test. And because the variances are not equal, you choose no, not pooled. And go ahead and hit calculate. We're using p-values, so we need to pull the p-value out of this. We've got p equals 0.007. That's less than 0.05, so we'll reject the null. If we reject the null, that means we're accepting the alternate, which means it's likely that the braking distances are not equal. Let's try another one. Computer City claims that the watt usage of its 21-inch monitor is less than that of Digital Dan's comparable model. Computer City's CFO orders a study and obtains the results shown at the right. At alpha equals 0.10, is there enough evidence to support the Computer City's claim? We're going to assume the populations are normally distributed and that the population variances are equal. Using p-values again. Because Computer City thinks that their computer wattage is less than the competitor, that's our alternate. The equal sign, remember, always goes in the null. So the null is that the mean of Computer City is greater than or equal to the mean of Digital Dan's comparable model. 0.10 significance level. We're using a left-tailed t-test. So if p is less than 0.10, we'll reject the null. And if p is greater than 0.10, we'll fail to reject the null. Into the calculator, we'll put in our sample data. We're doing a left-tailed test. And because this time the variances are equal, we're saying yes, the test will be pooled. Hit calculate, and this time we get a p-value of 2.49 e to the negative 4. Always be careful to be watching for that scientific notation. That's a really, really low number, so we can say that it's about 0. That is less than 0.10, so we'll reject the null, which means, again, we're accepting the alternate, which means that Computer City's monitor likely does use less wattage than its competitor. So, big samples, small samples. If you have really large samples, you stick into the z-distribution. If you have small samples, though, we need to go to the t-distribution. And in this case, we also have to see if we have equal variances or unequal variances. So there's some things to be looking out for. We're skipping the formulas for now, jumping right into the calculator, and that makes it a little bit easier. Have fun, good luck. Thanks for being here.